Welcome to the electronic archive of presentations from Performance Incentives, the growing impact on American K-12 education, a national conference hosted at Peabody College of Vanderbilt University in 2008. The conference was sponsored by the National Center on Performance Incentives, a research and development center funded in part by the U.S. Department of Education's Institute of Education Sciences. You are watching a video presentation from Dr. Daniel McCaffrey, a senior statistician at the RAND Corporation, on issues related to awarding teachers' pay on the basis of their students' progress.
Before I get started, I do want to thank Bing Han and JR and acknowledge them for the work they've been doing with me on this. It's kind of hard to follow Derek because he's kind of laid this groundwork where he sort of killed what I do. But I'm going to try and resurrect it by sort of claiming I'm just trying to solve a problem that everyone else has created, and that the idea is I think there are people out there who really want to take administrative databases, turn them into performance measures, and turn them into pay for teachers. And I want to talk about sort of how easy or hard that is and kind of walk you through. I say it's kind of like walking you through the sausage factory of getting from here to there. And I think there's an idea that this is a straightforward challenge, and I want to make sure that by the time we're done, you're not so convinced it's straightforward, but hopefully maybe not convinced it's impossible. So anyhow, the basic idea is well, like I said, we're going to work through these administrative databases, use these methods, and get there. I'm going to sort of organize my talk pretty much along those same ways. I'm giving you an outline because I'm going to have lots of sort of quick, fast changes through the points I make, and sort of wanted you to give a heads up so you weren't completely dazed and confused. So I'm going to talk a little bit about what you have to do to get the administrative data in shape. Then I'm going to turn over and go to a case study where we're actually going to look at some performance measures. I'll tell you a little bit about what that data is. Then I'm going to do some comparisons to those measures. And then if I haven't gone on for 40 minutes, I'm going to tell you a little bit about thinking about how you might make bonus decisions in a very simplified way, but I think that gives some insights into the way that how different things we do use data differently. Okay, so one of the key things when you start with the administrative data, the first thing you really need to do is start thinking about who's going to be in this data set. What teachers are really going to be used, what teachers can be evaluated, and who are the right teachers to be evaluated. I think there's a way in which administrative data doesn't have these answers. You have to sort of work this out of there, and these may be policies decisions that have to be worked out with the district. The testing does define sort of what tasks can be measured, but then there's challenges to thinking about which teachers really are doing enough of that task to really be measured using that measure. And the other thing that I think is really important to think about is that most of the measures we're going to use are relative. So the decisions you make about which teachers to include not only inform which teachers are going to be evaluated, but they also may make decisions on how other teachers' performance is measured. So if we make a decision about, for example, keeping in special education teachers, we're looking at middle school math teachers. If we keep in the special education teachers, that's going to influence how their performance is. That will influence how we measure other teachers' performance, because most of the measures we're going to use are relative and are comparing the performance relative to the other teachers that are in the sample. Some of the other kinds of issues that come up are issues like small classes. Well, from a statistical standpoint, keeping in small classes becomes a real problem because of some of the things I'll talk about later, things that were mentioned yesterday. We wind up having lots of noise. Those teachers with very few students, it's hard to make a good estimate of how well they're doing. But on the other side, do we want to tell teachers just because you teach a small class, your performance doesn't count, your students don't count? It becomes a sort of question of what do we inform people by the decisions we make, and these challenges are hard. Teachers are teaching multiple grades, and again, you have to start thinking about how do you combine this information across multiple grades? What's the appropriate way? And I think this gets to some of Derek's point. How do we value these various things? And then how do we build a measure that corresponds to those? Another thing that becomes very hard is identifying the courses you want to be part of the measure you do. It seems it's going to be obvious. You're going to walk in, you're going to have middle school math. That's well defined. Well, math actually turned out to be relatively well defined, so I'm going to talk about math today. When you get to some other subjects, it actually gets much harder. Even starting in middle school, in the English Language Arts department, you have teachers teaching drama, speech. Should those teachers be measured as part of this when you're doing the measurement system? What about a social studies teacher? In many schools, they teach a lot of writing and social studies. Interventions to improve writing are now trying to get writing in science class. Do we include those when we're measuring writing? These kind of decisions need to be made, and they're not just going to be obvious. So once we've gone through the process of trying to figure out which teachers, which courses, we need to identify the students. And again, now the real question is, what student's been in this teacher's class long enough for you to attribute that student's performance to this teacher? And again, administrative data doesn't tell us this. It may be a policy choice, but there's sort of implications on both sides. If we don't include students in, we're essentially informing those teachers that those students don't count. And we don't want to do too much of that because we want the students to count because of potential negative consequences. On the other side, if we start telling teachers, if a student's in your class for one day, you're accountable for them, that could have a very, really sort of degrade teachers' belief in the value of what we're doing. So this becomes a hard choice we need to make. Another thing that really becomes hard, and this shows up all the time, is that students are often taught by multiple teachers. They may be in both special ed and in regular classes. They may switch classes mid-year. They might be sort of being taught simultaneously because they have a reading teacher and an English language arts teacher. We need to figure out how to apportion that teaching to those multiple students. And there's multiple things you might do. You might do it in terms of how much instructional time they have, but in lots of times that's very hard to tease out. One of the things we found with our administrative data is actually figuring out exactly how much time students were in different teachers' classes was the one thing an excellent administrative data system didn't really tell us very well. It just isn't in that system. So getting that kind of information is something you may have to work hard to get in some other way, and it's not necessarily just going to fall out from just opening up the administrative data. The other data issues also come up, and for people who do research, these issues aren't new, these issues aren't novel, but I think the context is different. When we're doing research, we have algorithms, procedures we do to clean the data to get to the point we want, and in the end, we know that there's a certain amount of error we've probably introduced. We've convinced ourselves it's small and within the noise we're going to have anyhow, but we lose some records, or some records are fixed with fixes that we couldn't verify, and if someone's put the gun to our head and said, why did you make that choice, we'd have to say, well, we did it. When you're getting to a point where you're going to be making people's pay and they're going to be sort of scrutinizing this, those kind of decisions could come back to kill you. This recently was what came out in Dallas, where now all of a sudden, now that the teachers are being held accountable, they started to notice that there were errors where teachers who were teaching languages were sort of getting measured on their teachers for the French they were teaching, even though they didn't teach French. And other issues like that, and we saw this in our data too. We had a teacher who we said she taught history. She came back, she said, I don't teach history. We went back to the school, said, what's going on? They said, well, in our database, we could only have so many math classes, and we were over that, so we just put her class in as a history class. So, you need to get these things, but those kinds of things, if they're not corrected and dealt with properly, they could really erode anyone's confidence in the system. Okay, so now, like I said, this is going to be sort of a talk of hard changes. I want to quickly go over now to looking at performance measures on a case study. It's a large urban school district. The thing that's most important here is we have about 475 teachers, and about 340 of them are in 2 years. We're going to look at 2 years of data. We don't have multiple years of teachers, so we're just going to look at 2 one-year snapshots of our teachers. Another thing that's really important is we have a measure of the teachers that's called the LMT, and it actually, so we're going to have estimates of the teachers' performance based on their student scores. We also are lucky enough to have a measure of the teachers' knowledge for teaching that's based on multiple choice tests they took that's called the LMT, and I'll talk a little bit about that at various times. So now, in the paper, we look at 24 different performance measures, and I'm not going to talk about all of those. I'm going to focus on 4 today. I'd like to talk about all of them, but you wouldn't like me to do that, and I really don't have time. And the 4 I'm going to talk to, I've sort of classified into 2 groups. The first 2 are simple, and these are sort of line up with the T2 methods that Rob Meyer talked about. In fact, both these methods are ones he talked about yesterday. What I'm calling ANCOVA, he called value-added. I tend to use value-added as a sort of more broad umbrella term. He used it very specifically to talk about these measures where you use one prior year score to predict how students should behave, how students should perform, and then the difference, you get the differences of those and average those to get the teacher's effect. That's what we're calling ANCOVA. The gain score methods were talked about quite a bit yesterday, and this is the same procedures they were talking about. Then I also have 2 complex methods. One is a multivariate. They're both multivariate in the sense that they try to model all the students' data together We have a sort of more statistical model that I call multivariate mixed models. For people who are familiar with Bill Sanders' works, this is very similar to the kinds of things he does and other things that JR and I have proposed in the past. And then the fixed effects method is again, a joint model for all the data, but it's one that the economists use and takes a slightly different approach. And I'm happy to talk more about that at some other time, but for right now, if you just are willing to sort of buy, we have 2 simpler methods, 2 more complex methods. I think the main points will come out with that. Okay. So now I'm going to talk a little bit about how they perform, and I think the first thing we need to think about is sort of what's coming out when we look at these measures. And there's sort of really sort of 3 sources or 3 factors that are in there. There's a signal, which is telling us something about the true teacher's behavior. There's a bias, and this gets to some of what Derek was talking about. The fact that no matter what we do, we probably have something about the teacher's students lingering around in that estimate. And so we want to, that's what we're going to call bias, and we're going to look to try and figure that out. And then there's a piece that we call noise. It's just sort of the idiosyncratic piece that sort of deals with the students and things. And basically the idea with noise, if we had more and more students, that would get smaller and smaller. Okay, so what we've done is we tried to sort of come up with measures that sort of separated those out and sort of gave a really clear picture on how the different performance measures worked in terms of signal, noise, and bias. And that never really materialized perfectly. Because of very complicating factors. But what I do in the paper, there's a whole big table of many sort of metrics. I've looked at these measures. And what I've done here is I've sort of created a figure of them. And the idea is I've sort of measured them all sort of methods so that 0 is kind of the worst of all 24 measures. And now I'm looking at only our 4, but 0 would be the worst of all 24, and 1 would be the best, and then I've kind of scaled them in between. And the key picture here is over here on the far right are measures that are more about noise, and on the left are things that are more about bias and signal. And basically what I've done is I've sort of plotted there you have gains, ANCOVA, or what Rob called value-added, mixed models, and fixed effects. And as you can see, that as you go across the bottom, almost all the time gains and the ANCOVA methods are at the bottom, and often they're way at the bottom. And the gains in particular, when it gets to noise, are very noisy. And the fixed effects and the mixed models tend to be more likely at the top. Okay, great. And so quickly, a summary of what this tells us is that the ANCOVA method tends to have a large bias in the sense that it doesn't really get rid of the teacher's students very well and tends to sort of favor teachers. So you have 2 teachers who were equally performing. The teacher who was teaching in a better class, a class of sort of students who were higher performing coming in, would tend to get a better measure. The gains methods, as I noted, have had large noise. The mixed model methods tend to have what I would call small bias, from best I could tell, and also have smaller noise. This shows up in that they have the strongest correlation with the LMT. So this is kind of an independent measure of how much teachers know, and this measure has the strongest correlation with it. It also has relatively high cross-year correlations of 0.5. But it does have a certain amount of weak bias, I think, at least in this sample, in that it appears that teachers, if you took 2 teachers who were really equally performing and you put one in a class that was sort of kids who came in at higher performing, and the other in a class of lower performing, the one in the higher performing class would do better. Teachers with fewer % minority kids would do somewhat better. Not really largely, but somewhat. The fixed effects are sort of very similar, so our other complex method kind of has similar results, a little bit in the opposite direction. It seems that it might favor teachers who are teaching kids who actually are lower performing. So one of the things I really wanted to, I think I doubled. Yeah. Good. One of the things I think when I've seen these kind of comparisons before, and the one thing I really wanted to get at was, what does this really mean? What does this sort of tell us about what kind of teachers would this matter? And so what I did was I said, okay, well, let's take these methods and let's just say, how would the teachers who were sort of identified as significantly better than average differ if we use these 4 methods? And a few lessons came out really quickly that are really critical. And the main one is, I think it's really important, is that the value added, as Rob called it, or the ANCOVA method, it finds a lot more teachers that it says are significantly better than average. And those are not a random sample of teachers. Those are teachers teaching more likely to be white students, more likely students who are coming in performing well. I don't have free and reduced lunch, but here I have a race, and I'm sure it's very highly correlated. The other thing that's really important is those discrepancies persist over time. So the teachers it finds in 1 year as sort of being there and none of the other methods do, they would be found year after year. So this is this measure is the Hillsborough fiasco waiting to happen. It's going to sort of award the teachers in the better schools, and it's going to do it consistently, and people are not going to have faith once it does that. The fixed effects and multivariate methods, which are both sort of more complex methods, they perform much more similarly. So we have, they correlate about 0.86 in this data set. What's really important is they agree on teachers who are above average for 90% of teachers. And when they disagree, they disagree kind of in the way the bias would suggest. That the mixed models tends to favor teachers who are teaching somewhat better students. It also tends to favor teachers who are scoring higher in the LMT. The fixed effects sort of tends to favor the teachers who are teaching the sort of higher minority classes, but it also seems to go against the LMT. So I'm not exactly sure what that's telling us, but those differences are relatively small. And the really interesting thing is they don't persist. So teachers who are sort of getting classified differentially 1 year don't have it happen repeatedly. So now I'm going to turn over to a little bit about bonuses, and I'm going to kind of consider a relatively simplified way of thinking about this. So the idea is if you were going to give bonuses by sort of awarding people for being over a threshold. And that's not exactly what people do, but it actually, I think it's fairly, the lessons we learn here transfer pretty well to things if you were going to give people who were in the top quartile or something like that. Pretty similar kinds of things would happen. I'm going to do only focus on some analytic work. We did some empirical work, but pretty much the lessons from that really mimic what we learned by just looking who they were assigned as being above average. So what we did was we said, okay, let's consider 3 rules that you could, actually there's 8 rules in the paper, but I'm only going to talk about 3. So we said there's 3 ways you might assign a bonus. If you take a performance measure, you set up a threshold, if that gets over the threshold, you get a bonus. The other one is, well, but we know there's error in that, right? So what do you do when there's error? You do a statistical significance test. So the second method is you're going to award the bonus if people are significantly over the threshold. And the third one is, what we're going to do is we're going to sort of figure out the probability that someone is over the threshold, given what we know about them, and then we're going to award the bonus proportional to that probability. So the first 2 are all or nothing. If you're over the threshold or your confidence interval is over the threshold, you get a bonus. If you're not, you don't. The third one is we're going to give you an incremental bonus by how confident we are that you really are over. Then we considered 3 levels of sort of noise in our estimate. So the dark line, the solid line, is really small noise, so it's a really good estimate of the teacher. The second one is, the dashed one is about 10% of the error is noise, and the dotted one is about 25% of all the variance that we know about teachers is noise. And what you can see is as you get more noise, what happens is you do it, I think we all know. This is not sort of really enlightening, but it just sort of demonstrates what happens. When you have noise, you start awarding teachers who are over the threshold, you stop giving them bonuses, and the teachers who aren't, you start giving them bonuses. And that's what the effect of noise is you start misallocating and making mistakes of what you want to do. What I think is really interesting about this is what happens by using the confidence interval method, doing the statistical test. What you can see when you look at the middle plot, what happens then is that all of a sudden, all the errors now have shifted from being symmetric around the threshold to all being on the one side of the threshold. Because what doing the test says is we really value the cost of making an error where we award a bonus to the wrong person is very costly. So we're going to push all our errors to that side of the threshold. But it doesn't cost anything to not give bonuses to teachers who shouldn't have them. And so what we've done is by making that choice, we've implicitly made a decision about how costly it is to make these 2 different kinds of errors. But the reality is that's a statistical choice. That has nothing to do with the real cost to motivating teachers through using this kind of performance measure. So the point is that this has the effect of making it a choice about how we value errors in a case where we don't know how we should value those errors. Another thing that might motivate people or affect people's motivation is how much uncertainty there is in the bonuses. So what I've done here is I've plotted the amount of variance you have given your true level of performance, how much variance there might be in your bonus. And what you can see is the all or none ones have a lot of variance because if you make a slight error in your measure, you don't get anything, or you might get anything. So there's a real big error. But the one where we give the small increments, because we always give just a small change, you can really you can reduce that uncertainty. So by changing your decision rule, you can manage the uncertainty. One of the things that I think is interesting when thinking through this is that, do we want to manage the uncertainty that way? I mean, one of the things is if people are averse to uncertainty, in the first two methods, to get to a place where you have a high bonus and low uncertainty, you need to move your performance to a very, very high value. In the last case, you can just sort of stay where you are, and you don't really have to change anything to sort of change the uncertainty. So getting rid of uncertainty is possible, but it may have a negative effect on motivation. Those two were kind of basically ignoring the issues of bias, but bias doesn't really affect that story. It just kind of moves around where that story exists. So basically what bias does is it says that two teachers who are of equal performance don't necessarily have the same probability of getting a bonus. And what I did was I said, okay, I sort of took bias that was similar to what you would get with the Ankova method in terms of how it was a function of the percent minority kids, and said, okay, if we had that much bias, how would that distort the distribution so that if a teacher was in a class that had 0% minority kids, how much bonus would they get averaged over all teachers relative to a teacher who was 100% minority? And this is a bit simulated and a bit synthetic, but it kind of gives a point that bias really does change things. As you can see, you go from sort of, if teachers who had very low percent minority kids would sort of have somewhere maybe 50% chance of getting a bonus, as they get to around 80%, they get down to around 10%, just because of the strength of this bias distorting how hard it is for them to get a bonus. So I'm just going to skip over these. Basically, those are just summaries of the same lessons we learned, and I just want to end with this idea that I think is something brought up last night. I think it's really, what I learned when looking at all this is that there's a lot of things we really don't know. We don't know how teacher values these different things. We don't know how they value these certain kinds of areas. We don't know what will motivate their change in terms of how much bonus they need, how much uncertainty matters, and whether seeing that teachers in different contexts get different awards, will that destroy their confidence in the system? Will that change how they value it? And how does that matter in terms of what the overall system is doing? And so we need, I think, to get that kind of feedback, we need to start getting the teachers' input and telling us how they value these different parts of the system, so we can then make decisions as we go through the system that sort of at least are consistent with what they believe.
A working paper and the PowerPoint slides used in this presentation are available on the National Center on Performance Incentive website.